Welcome to this video on the techniques of firefighting. This series explores essential engineering safety measures. Welcome. Today, we look at why firefighting matters in engineering. First, industrial facilities like plants and labs continuously manage fuel, heat, and oxidizers, making fire a constant hazard. Second, understanding fire safety directly protects lives and physical assets, reducing operational downtime and costly equipment damage. Third, regulatory compliance is essential. Engineers design, test, and certify safety systems according to strict standards like NFPA and OSHA throughout a facility's lifecycle. Finally, site engineers are often the first responders on scene before emergency services arrive. Proper training ensures you can take critical action under pressure to mitigate risks immediately. Next, let's explore the fire triangle and tetrahedron. To ignite, fire requires three key elements: fuel, heat, and oxygen. Fuel includes any combustible solid, liquid, or gas. Heat acts as the ignition source, bringing fuel to its combustion temperature. Oxygen, usually supplied by air, must reach a concentration of at least 16%. Remove any single element, and a fire cannot exist. However, once ignited, a self-sustaining, uninhibited chemical chain reaction keeps the fire burning. Adding this critical fourth component expands the classic fire triangle into the fire tetrahedron, which forms the foundation for modern fire suppression techniques. Now, let's look at the distinct classes of fire, as selecting the right suppression agent depends entirely on the fuel source. Class A covers ordinary combustible solids like wood, paper, and plastics. Class B applies to flammable liquids including petrol, oil, and solvents. Class C involves flammable gases such as methane and propane. Class D addresses combustible metals like magnesium and titanium, which require specialized extinguishing agents. Class E deals with electrical fires in live wiring, motors, and control panels. Lastly, Class K covers high-temperature cooking oils and fats. Understanding these categories is critical to tackling fires safely and effectively. Here are the 4 core principles of fire extinguishment, each working by breaking a specific leg of the fire tetrahedron. First, cooling removes heat. Using agents like water lowers the fuel's temperature below its ignition point. Second, smothering cuts off oxygen. Tools like foam, carbon dioxide, or fire blankets deprive the fire of air. Third, starving removes the fuel source, achieved by shutting supply valves or physically clearing nearby combustibles. Finally, chain breaking interrupts the chemical reaction using specialized dry chemical agents. Targeting even one of these 4 elements effectively stops the fire. Let's cover portable fire extinguishers and their proper applications. Water cools Class A fires, but avoid using it on electrical or Class B and C hazards. Foam smothers Class A and B fires, but never live electrical equipment. Carbon dioxide smothers Class B and E fires by displacing oxygen, though unventilated confined spaces should be avoided. Versatile dry chemical powder interrupts chain reactions across Class A, B, C, and E, but leaves residue on delicate electronics. Finally, wet chemicals cool and saponify Class K cooking fires, while specialized Class D powder smothers metal fires through crust formation. To operate a portable fire extinguisher effectively, remember the acronym PASS. First, pull the safety pin, breaking the tamper seal. Second, aim the nozzle low, pointing directly at the base of the fire rather than the flames. Third, squeeze the handle steadily to release the extinguishing agent. Finally, sweep the nozzle side to side across the base until the fire is completely extinguished. As a vital rule of thumb, only attempt to fight small, contained fires when you have a clear escape route behind you. Otherwise, evacuate immediately and call for emergency assistance. Beyond portable units, facility protection often relies on fixed automatic fire suppression systems. Sprinkler systems feature heat-activated heads that discharge water targeted specifically over affected zones, available in wet, dry, pre-action, or deluge configurations to suit different environments. Foam suppression is essential for fuel storage and processing areas, blanketing liquid surfaces to smother flammable vapors. Clean agent or gaseous systems using CO2, FM200, or Energen protect sensitive environments like server rooms and switchgear without damaging electrical components. Finally, water mist systems produce microdroplets that cool fires and displace oxygen, making them ideal for enclosed spaces where minimizing water damage is critical. Early detection buys critical time. The sooner a fire is sensed, the more options responders have. Smoke detectors use ionization or photoelectric sensors to detect airborne smoke particles, providing the fastest response for smoldering fires. Heat detectors rely on fixed temperature or rate of rise thresholds, making them ideal for environments prone to ambient smoke or dust, like kitchens, garages, and industrial spaces. Flame detectors utilize UV or IR sensors to detect open flames almost instantly, making them crucial where fast-flashing fuels are present. Finally, alarm and notification systems connect sounders, strobes, and building controls to trigger immediate evacuation and automated emergency responses. Now, let me walk you through key firefighting techniques used specifically in industrial sites. Water curtains and cooling jets shield adjacent tanks and infrastructure from intense radiant heat during pipeline or vessel fires. Foam blanketing is applied over spilled hydrocarbons to suppress volatile vapor release and prevent reignition. Fuel isolation utilizes emergency shutoff valves, ESD, to cut gas or fuel flow remotely, starving the fire at its source. Inerting and purging uses nitrogen or steam to displace oxygen inside equipment before hot work or post-leak operations. Finally, fire-resistant barriers provide passive protection to slow flame spread, while trained emergency response teams execute pre-planned scenarios until municipal services arrive. To wrap up, let's review essential fire safety do's and don'ts. Do: know your exit routes and assembly points before an emergency occurs. Raise the alarm immediately and contact emergency services. Select and use the correct extinguisher class for the specific fire type. Keep all escape routes and extinguisher access clear at all times. Don't: never attempt to fight a fast-spreading fire or one blocking your exit. Never apply water to live electrical equipment or Class B liquid fires. Never re-enter a burning building to retrieve personal belongings. Never disable, prop open, or block fire doors, alarms, or sprinkler heads. Thank you.